So today's topic is network forensics. This is very important. You analyze network traffic to find out what happened. This is part of almost every breach. Usually the bad guys come in, they infect your machines with malware, and then they steal something. They came there to steal proprietary technology, credit card numbers, or something. And all this involves network traffic, and you can analyze the network traffic to detect and respond to these breaches. So there's two basic ways to do it. One is real-time capture and analysis, with things like intrusion detection systems that will detect an attack in progress, and then retroactive analysis of captured data. So here's some tools: Encased Endpoint Investigator, RSA, NetWitness, Kibana, Carbon Black, Splunk, Wireshark, and many others are used for this in various ways. And we're going to use Wireshark later in the project. So here's some network devices you should know about. This is sort of the Net Plus part. So proxy servers stand between the servers and a client and forward requests. Web servers, of course, store web documents, and a uniform resource identifier is the name of the page, like what you see it up here, company.com, and then maybe a folder and other parameters to determine which page you're going to see. And you send an HTTP request to the server, you get a response code. 200 means success, 300 means redirection to another site, 400 is an error that it can't find the page, 500 is a server failed on the service. So script failed on the service. So those are the kind of response codes you get. Your browser handles these. And on the server, you're running scripting languages, things like PHP or Python or Ruby, or running on the server. These are what handles data you send up there. If you log in or fill in an address form to make a purchase or something, that data is passed up to a script on the server, which processes it. When you connect to a network, like when you boot up your laptop at a coffee house, the first thing your laptop does is send a broadcast request to find an IP address. It says, I'm on the network, I need an IP address, and DHCP servers are what gives you that address. Email servers, of course, forward and deliver email. DNS servers resolve alphabetical domain names to IP addresses. There is a local hosts file in every machine, which can be a static mapping of domain names to IP addresses, but in most cases the host file is unused and empty. There are attacks that poison the host file with false addresses to trick your browser into going to the wrong server for certain sites. Like DNS Changer is one of the ones that did that, or it did something related to that. Let me check for comments on the Twitch. Okay, nothing new. All right. Switches connect devices on a local area network, and they route traffic by MAC address. They switch traffic by MAC address, so they read the MAC address and only forward the packet. I'm trying to use the right term. They only forward the frame out the correct port. Hubs are the old-fashioned, lower, stupider device that simply forwards all incoming data out all the other ports, so data is sent to machines it's not addressed to. These things are almost never used anymore, but in wireless networks it acts like a hub, because the physics of wireless transmissions are that they go in all directions, and you cannot send them just to the one device that you want them to go to. They will go to all the devices nearby. An intrusion detection system will monitor network traffic and look for suspicious patterns of bits. And when it finds them, it will raise an alert or perhaps change a firewall rule to block it. And firewalls are the security measure that blocks traffic. It has a list of rules, what kind of traffic is allowed, what kind of traffic is forbidden, and it prevents the forbidden traffic from passing onto your network or perhaps going out of your network. There's other technologies. Pretty good privacy is an email encryption solution. It's very strong. IP version 4 is the most common addressing scheme, but some of us are using IP version 6. Let me just bring up a terminal, I can point that out. If you go to my IP address right now, I'm in a hotel, and so I have a IP address, IP version 4, 10.0.54.111, and whenever an adapter comes up to a usable state these days, it automatically configures a link local IP version 6 address, and that's what you see there. Just a lot of hexadecimal. It's 4 times longer than an IP version 4 address. This is condensed. The colon means a whole region of zeros, but that's what IP version 6 addresses look like, and almost all devices are now using both IP version 4 and IP version 6. All right, and here, by the way, this is DHCP can change your host name. I saw this earlier and I wondered what it is. It must be the hotel network that has this bizarre host name, Deckley Nod Touch 7. It appears on my terminal, and I thought I'd been hacked, but it's just something a DHCP server can set, is the name of the local network. It's just a strange thing to set it, and it's a very strange thing to set it to such a strange name that makes no sense. Anyway, subnetting is breaking a IP network into smaller pieces so you can restrict traffic to local areas. And MAC addresses are the 48-bit addresses that define the interface. That's secure-marked ether. That's a MAC address. 6 bytes, each byte being 2 hexadecimal characters. It's it's built into the network interface card when it's built and normally never changed. And it's supposed to be a different number for every network interface card in the world, effectively a random number. Ports are TCP ports and UDP ports. They are addresses so that the IP address tells you how to connect to the actual computer you're trying to find where it is in the world. But once you get there, it might be offering several services like web services and FTP and email. And so you use the port number to tell it which service you're trying to reach on that server. The OSI model is a layered model describing these layers, and we'll see them later when we get to Wireshark. The physical layer at the bottom is the medium through which data is sent, like a cable or a wireless transmission, and layer 2 uses MAC addresses, layer 3 uses IP addresses, and layer 4 uses TCP and UDP ports. And in the OSI model, there are 3 layers above that. In the TCP model, there are only 4 layers, and they're sort of combined into a smaller number. Voice over IP is used to send telephone calls over normal computer networks, and it's what most of us are actually using these days. Let me check for comments in the Twitch. Nothing new? Okay. All right. So incident response is what happens when you have a security incident, like somebody is infected with a virus or a violation of security policy. Then you monitor for things like unusual login attempts or malware, unusual connections, people logging in from strange locations or at the wrong time of day. These are things that can cause a security incident. And when you declare an incident, then you have an incident response process, which is like when you have, you might have a concern about a fire and somebody verifies there's really a fire, they pull a fire alarm, now you have a response to that situation. So the incident response team will include technical people doing digital forensics, a legal team, public relations, human resources, and many more, as the incident may affect many parts of your business. Threat intelligence is a big consideration these days. People subscribe to threat intelligence feeds, or they use free open source ones, which list what's going on. A lot of the news I talk about at the beginning of every class is what the hacking groups are doing, what tools they're using, what new vulnerabilities have been found. So you have to be aware of what sort of attacks are likely to be coming in. All right. And you can get information of this that you can share with security organizations you can join, like the Electronic Crimes Task Force. I'm a member. That's the Secret Service. And CISA, it puts out a lot of useful information and so on. Advanced persistent threats are usually attacks from enemy military. Although they can be large crime groups, they are people who are very sophisticated, and typically what they will do is intrude on a network very quietly and plant monitoring software on the network and not get caught. They will just stay on your network and spy on what you're doing to steal something, and typically be there for a long time. That's the persistent part, and they're very hard to detect and remove because they're very skilled attackers. So around 2010, there were many American companies found that China had compromised them for years and been stealing their data for years, and they had planted malware that would sleep and then wake up later with a sleep period up to 3 years. So you can think you cleaned it off and you're safe, and it will wake up and put you under, return you to being controlled by China again. All right. They use a lot of techniques. And one technique is when you analyze the files, they might do time stomping, which changes the time stamps on files, so you cannot tell that a file has been recently modified. It will look like it hasn't been modified since the operating system has been installed, and so on. The cyber kill chain is one of the earlier attempts to make a scientific model of how these attacks work, breaking it up into stages. First, you have reconnaissance, where they research your company to decide what the attacks they want to do. Then they create a weapon of some kind. Then they deliver that weapon with something like an email or an SMS message. Then they exploit a machine and gain control over it. Then they place that machine under persistent control with a command and control center server, and then they can exfiltrate data, steal data from your network and sneak it out so you don't detect it. So the reconnaissance will include things like job postings, press releases, Facebook, LinkedIn, websites, tech forums. They will just research your company to find out what kind of technology you use, what skills your employees have, and what you have that might be worth stealing. Then they somehow make malicious code, put it in something like a PDF file, deliver it somehow, and then get exploitation of the payload. Somehow trick somebody in the company into clicking on a link or opening a file, and then you have that machine compromised, and it can now communicate out to a command and control server and then get various commands to do various attacks. And eventually you steal data from the network. In the more modern version of this, by the way, I might as well bring it up, is the attack framework, which is just a more modern update to the cyber kill chain. Here's the attack, right here it is. And this breaks it into like 14 stages. So if you go to the matrix, the enterprise matrix is here, and instead of just that 5 or 6 stages, it's got reconnaissance, resource development, initial access, execution, persistence, privilege escalation, defense evasion, and I'll scroll to the right if I can get a scroll bar to appear. There we go. All right. So you got defense evasion, credential access, discovery, lateral movement, collect, command and control, and see if I somehow make it go to the right. There we go. All right. And exfiltration and impact. And not every attack does all of those stages, but they all do some of these stages. And the MITRE ATT&CK framework also lists all the current techniques that various people are using to do these. And we go through this a lot in my instant response class. Let me check for comments on Twitch. Do all ex-Typhoon APTs steal data? No, there are many. There's a very good question. Stealing data is not the only reason. Some of them, for example, destroy the machines, wipe the drive. Some of them do other things. Just exfiltrating data is one of the more common payloads, but they have a mission and they do whatever would suit to accomplish their mission. Yeah. A very good question. And you're quite correct. It's not always exfiltrating data. That's one sense in which the Lockheed Martin kill chain is unnecessarily limited, and that more modern attack framework has a whole variety of possible payloads. Stealing data is just one of them. So your attack group has tactics, techniques, and procedures. These are the ways they attack you and ways you can tell which group is attacking you by what techniques they use. And that was in that attack matrix. Will list the various techniques that people use, and each attack group will have a known list of techniques they commonly use. Yara is a tool that just quickly classifies and identifies malware by looking for patterns of byte or text in it. Persistence is the process of making your machine, putting a machine under control of the attacker and making sure it stays that way so it will survive, say, a restart or turning off the browser or other things that people might do. You put in some kind of automatic restart function, typically through the registry, so it will automatically restart the malware after the machine is rebooted. Let me check for comments in the Twitch. All right. And DIL sideloading is the most common way that machines get infected. And we do this in the malware analysis class. I think we've set this up. You can Windows programs dynamically load libraries while they're running, and you can trick them into loading a malicious library instead of the genuine library, and that's the most common way for code to execute on Windows machines, attackers' code. So you remediate. When you find an intrusion, then you remediate this by blocking IP addresses at the firewall, disconnecting part of the network, and then you generate indicators of compromise, which are something you can measure on other machines to see if they've also been infected. Something like a file that's created, or a running net process in memory, or a network connection. Then you figure out remediation activities to clean up all the machines so you can restore them to use. You find the root cause to find out fundamentally how they got in, and you have to have a plan to block it. And that what you should do is you analyze the intrusion for a while until you have figured out what happened, and then you have a single eradication event where you replace all the infected machines with clean images and block the attack at the firewall or what else you have to do. So hopefully you kick the bad guy out and you block the door they came in. So you actually get rid of them. It's quite difficult, and often it takes more than one eradication cycle to get rid of them. So indicators of compromise are something you can easily measure to tell if a machine has been compromised according to the attack. So things like prefetch files, email, DIL files, things like that, something in a log, something you can easily find that will tell you which machines have been involved in the attack and compromised. So investigating random access memory is necessary to understand these. Most attacks do not put files on the disk, they just run in memory. So what's running currently in memory is often very important to see if a machine is involved in an attack. The ham cache, shim cache is a tool that Microsoft, it's part of Microsoft Registry, and it is just a place where it records which programs have been run in order to consider whether to put a shim on them, which is a piece of software to make code written for an earlier version of Windows run on a modern version of Windows. That's why they're doing it, but it has the result of creating a list of programs that have been run, and that's quite useful. Shellbags identifies which folders have been opened, and volume shadow copy contains old versions of files, so if people have been changing things, you can often tell from the shadow copy what was changed and when it was changed. And here's some tools that help. Carbon Black is an endpoint protection tool from VMware. Kibana is part of the ELK stack. Elasticsearch, Logstash, and Kibana create an SIEM system, which is a competitor with Splunk. Splunk is very expensive, but it's very luxurious, and it makes it very easy to search through all your log files and find out what's been happening. If you don't want to pay for Splunk, you can do it for free open source tools. Elasticsearch, Logstash, and Kibana give you a similar functionality in open source tools. And Log2 Timeline is another way to just make a timeline of the events that appear in logs. And SandSift Workstation is a Linux distribution intended for instant response. It's the one you'll use if you take those expensive SANS classes. So that's here. Let me check the Twitch. All right, let's try a Kahoot about this stuff. It's mod 8. All right. All right, so what does the hosts file do? It does DNS resolution. It resolves alphabetic domain names to IP addresses. All right, which device will send all packets to every host on the network? That's a hub. Hubs are dumb. Every bit of data that comes in is sent to every other device on the network without knowing anything or reading anything about the addresses. All right, which powerful attackers are usually foreign military? Yep, those are the advanced persistent threats. All right. All right, what phase of an attack communicates with an external server to get instructions? That's command and control, called C2. All right. All right, good.